That's odd. All right, good morning. We are set to do section 11.1, where we're solving quadratic equations by completing the square. And here are some preliminary examples starting with page 756 of the textbook, where we are first going to go over, we've already been doing this, using the square root property to solve our equations for x. So without further ado, and then there's another technique that I have to implement here, and that will carry over into our new learning of solving quadratic equations by completing the square. So let's see, in my first example here, I've got x squared equals 50, so I want to get x by itself, so we take the square root of both sides. And then this left side is just going to be x equals, and now technically the square root of 50 has to be plus or minus the square root of 50. And I talked about in class the reasons why. So we've got now the plus or minus square root of 50, and now I have to simplify the square root of 50. So that would end up being that x equals, let's see, I'm going to take out, let's see, it's plus or minus, so I can take out a 5, and then I'll have root 2 left over. Alright, so we've been working on these, practicing the simplification of a square root and cube roots and the like. So I'll leave it up to you to be able to figure out what I've done there and the rest of these problems as well. Alright, example 2, I'm just going to move over here. Example 2 is 2x squared, and that's going to equal 14. Alright, so what do I do here? Now I want to get the x squared by itself, so that means this 2 has got to be divided out. And I do that to both sides, whereas on my left side now is going to be x squared, that equals 7. At this point I take the square root of both sides, where x is going to equal plus or minus the square root of 7. I can't simplify the square root of 7, so this remains as my solution. X equals positive square root of 7 or negative square root of 7. Alright, as you can see here, I've got a binomial squared. So the methodology is basically the same. I'm going to take the square root of that term, and this is one term here. So simply put, I'm going to say, what is the square root of x plus 1 squared? That equals the square root of 12. So this is going to be the left side here, you can see, is going to be the x plus 1. That equals plus or minus the square root of 12. Okay, next I can simplify this now, this square root of 12, where I would have x plus 1 that equals plus or minus, let's see, what can I take out of there? A 2 comes out, and then I'm left with the square root of 3. And then lastly, to get my x by itself, I've got to subtract 1 here. Subtract 1. And notice where I'm doing this at. I've got x on the left side equals this minus 1. I'm not combining it with the 2 root 3 at all. I'm going to put it in front of the plus and minus sign. So it's going to look like negative 1 plus or minus 2 square root of 3. And this now is my solution. X equals negative 1 plus or minus 2 root 3. You remember, in our answers there are no decimals. We have to use exact answers. Okay. What's example 4? Turn the page, and I've got basically another one, and it looks like something slightly different. 2x minus 5, that's squared, and it's going to equal a negative number. negative 16. Okay, so nothing to do here but take the square root of both sides. And notice I'm taking the square root of a negative number, so that should alert us to the imaginary numbers. All right, so the left side is going to be 2x minus 5. That's going to equal, what happens here? Well, the negative 1 times 16, I can break that down. Remember, this is equal to the square root of negative 1 times 16. So the square root of negative 1 is I. I can bring that out front. And the square root of 16 is 4. So it looks like I can make a slight change with that and make this be 4I with a plus or minus in front of it. All right, then what's left to do is to add 5 to both sides. So now I'm going to, if I add 5 to both sides, remember I do not add it to the 4I in any capacity. Those are unlike terms anyway. So then I bring down the 2x, and that's going to equal 5 plus or minus 4I. Lastly, divide by 2. So x equals 5 plus or minus 4I, all divided by 2. And that's the way you write your answer for that. Okay, unless it said to write it in a plus bi form. If it says that, then you just have to do some rearranging here. But we won't worry about it right now. Next example. Okay, before we get on to the example, I first want to point out that these three trinomials here are examples of perfect square trinomials. Okay, they are called perfect square trinomials because when you factor them, they have this unique look of being a binomial that's squared. All right, so for example, I'll do all three of these real quickly. And if I fill this in, the lead coefficient is 1, so I know this is the easy one. So when we fill them in, I've got x and x. All the signs are positive here in these examples, this example. And so my two numbers that multiply to be 16 and add up to be 8 are the same number of being 4. So then likewise I can write x plus 4 up as x plus 4 and then square it. And these are building blocks for when we do the completing the square method for factoring trinomials. Perfect square trinomials, that is. Okay, so this can be, in the future, then I'll be able to take the square root of that. And that's where we're headed with this. So this x squared minus 6x plus 9, same thing here. I'll copy down my sign here. These are both negative in this case. And I've got 3 and 3. So this can be written x minus 3, and I'll square that. Okay, lastly, another perfect square trinomial. What do we know? X and x, positive, positive, 7, 7. And therefore this becomes x plus 7, and then we square it. All right, so now the task at hand is we have to write perfect square trinomials. And how do we do that? If given I just have this example 5 now, is that x squared plus 6x. And I have to write the third term. How do I figure out how to write the third term? And the way you go about doing that is to take the middle term, b, if you will, and I'm going to take it and literally do it on the outside so you can see what you're writing and see what your numbers are that you need to fill in when you factor this. So the job here says to add the proper constant to x squared plus 6x so that the result is a perfect square trinomial, and then to factor that trinomial. Okay, so this is how you go about doing it. Take the middle term 6, divide it by 2, and then square it. Okay, so what happens here? This 6 divided by 2 is 3, and 3 squared is 9. So we would always add 9 to this case here. Now when I go to factor this, well, this is easy to factor, but in the future I want you to note when they get a little more complicated with fractions as our constant, that herein lies our number that we need to fill in our factorization, and that is going to be the 6 divided by 2, which is 3. So that's where the 3 would go here and here. And then I could rewrite this to be x plus 3 squared. And there, example 5 is complete, and that's how we want to do that. How about another? Let's see, I've got the next one is x squared minus 3x, and I have to write the perfect square trinomial for that. All right, this is example 6, by the way. All right, so I'm going to take the 3, divide it by 2, and then square it. So let's see, that gives me 9 over 4. So I'm going to add 9 over 4. And then when I go to factor this now, it's going to look like the two binomials multiplied together. So I got x here, x here. I'm going to write down my signs if this is negative, and they're both going to be negative to get me the positive. And then what are my two terms that go here and here? Or my one term? They're going to be the same number. But that same number lies in here, inside the parentheses, which is the 3 and the 3 over 2. Just this part here. So this is going to be 3 over 2 and 3 over 2. That is your factorization of x squared minus 3x plus 9 over 4. And then again, you can write it up as x minus 3 over 2 squared. Okay, and that's it for that section. That's how we create perfect square trinomials. All right, our next objective here is to solving by completing this square. So that's next coming up. Okay, here's example 7. And we start off with a trinomial. I could subtract 4 from both sides and try to factor that. And watch, you know, I've got p, which is a logical thing to do. We always want to try and do it the easier way whenever we can. However, if I go to attempt to do this, and I subtract 4 from both sides to get the quadratic equal to 0, which you're supposed to do, then when I attempt to factor this, I have, let's see, I'll set up my parentheses, and we'll see that I got a plus minus and a minus here. And then I trying to figure out two numbers that give me negative 4. When you add them, I want to get positive 2 and multiply to be negative 4. My phone's going off, it's distracting me. But the case in point here that there are none. There are no factors there. So instead of saying it's unfactorable or a prime, now we can create this this factorization by doing what is called completing the square. So what I want to do here, whether I could start here or go back to this one to say I want to clear the spot here for my perfect square trinomial, which I can already, because this would be rewritten as p to the second power plus 2p plus something. Give it a little space that equals this 4. Okay, and now the trick here is to finish this left side with a perfect square trinomial. So I got to figure out what number goes there. And whatever number I put there, I have to add to the other side as well. So let's see, I'm going to have 2. I'm going to take out the 2, I'm going to divide it by 2, and then I'm going to square it. So 2 divided by 2 is 1. 1 squared is 1. So I'm going to put 1 here, add 1 to the left side, and add 1 to the right side equally. Okay. Next is I'm going to factor this p squared plus 2p plus 1. All right, so that I can factor now. And that'll be p plus, and what's two numbers that multiply to give you 1? Can only be 1 times 1. And that's going to equal the right side of 5. Just the 4 plus 1 is 5. So at this point here, I've got p plus 1, and I want to write it squared, equals 5. Now I'll go ahead and take the square root of both sides. And now I've got p plus 1 equals plus or minus the square root of 5. And finally, get the p by itself by subtracting 1. Subtract 1. And I got a final answer of p equals -1 plus or minus the square root of 5. And there's our first example of completing the square. Okay, here we are, example 8. We observe the problem, kind of look at it and see, can I factor it by traditional ways? And of course the answer is no here, because if I have a 1, what two numbers multiply to be 1 and add up to be 7? Well, we know that's just not going to happen. So we'll solve this by completing the square. So I've got a -1 here in the position that I need to clear in order to create the perfect square trinomial. So I'm going to just start by adding 1 to both sides. And that'll give me m squared minus 7m plus something that equals 1. So I brought that 1 over to the other side. And now I'm going to create the trinomial that I need, the perfect square trinomial, by taking the 7 here, divide it by 2, and then squaring it. Really important to do it on the side column there, you know, your little scrap area, work area, however you want to call it. So now this 7 divided by 2 squared, this is going to equal 49 over 4. So I got 49 over 4. I added it to this side. Now I have to add it to this side as well. 49 over 4. Now I can factor this left side. It's a perfect square trinomial, so I know it's going to look something like this. M minus, both minus. And my number here that I put in these binomials is right here. It's the 7 over 2. Okay, and that's going to equal, now I got to add these two guys up here as well. So let's see, let's do that. So this is really 1 over 1, so I'm going to multiply top and bottom by 4. So I get my denominators to be the same. And so 4 times 1 is 4 here. 4 plus 49 is 53. And that's going to be over 4. Make sure you know how to do your fractions now. Really important in this section, in all of math, really. But for now, we've got this as 53 over 4. And then I can rewrite this to be m minus 7 over 2 squared. That equals 53 over 4. Now we got it in the position we want, so we'll take the square root of both sides. And now when I get fractions here, I'm gonna separate it. I see that 4, and I know that 4 is a perfect square number, so I'm just going to do it separately. It works for me anyway. So the left side is going to be m minus 7 over 2. And this is going to equal the right side. And the right side now is going to be the square root of 53 over 2. And that's fine with me. Nothing I can do with that square root of 53. The square root of 4 is 2, so that comes out of the radical sign. And the last thing to do is to add 7 halves to both sides. So I'm going to add 7 over 2 to both sides. Let's see. I remember this is plus and minus. I got to have that there. So if I add 7 over 2, it's okay here. But when I rewrite it, you really kind of want it as 7 over 2 plus or minus the square root of 53 over 2. And then you've got, you can leave it that way. If it's a, paper pencil test, you could write it as 7 plus or minus the square root of 53. What's going on here with my, can't make a 5 today. Square root of 53, put it all over 2, so either way is fine. All right, and that's our solution for example 8. You can see it gets a little bit more involved as we go along. Okay, here's our last example, and this one's different now because the lead coefficient isn't 1 any longer. Notice in this case I've got a 4. So when we get problems similar to this where the lead coefficient is not 1, what we have to do is we have to make it 1. And we make it 1 by dividing everything by that lead coefficient. So in other words, this is 4, so I'm going to make that just a 1x squared, so I have to divide everything by 4. So let's go ahead and do that. And I'm even doing the 0 there, even though we know it's going to be 0, remain 0. All right, so as I do that, then it's going to start to break down to be x squared minus 6x plus this 41 over 4 that equals 0. And that's how it's changed. All right, so now I've got this 41 over 4. I'm not even going to try to solve that the traditional way. I'm going to complete the square with it. So I'm going to subtract 41 over 4 to both sides. So that breaks this problem down, and it's going to look like it's like x squared minus 6x plus something that's equal to negative 41 over 4. Okay? Let's see, now I'm going to take the 6 on the outside, divide it by 2, and then square it, and we had this earlier. So let's see, when I do that, I'm going to have 6 divided by 2 is 3, 3 squared is 9. So I'm going to add 9 to the left side as well as to the right side. My left side is going to be x minus 3 times x minus 3. Which is going to be x minus 3 squared. Okay, and the right side here, I've got to add this together. So let's see, I'm going to get my denominators the same. So I'm going to multiply the bottom by 4 as well as the top. And so 9 times 4 here is 36. And this is going to end up giving me a denominator of 4. And what's negative 41 plus 36? Negative 5. So my right side here ends up equaling negative 5 over 4. Great. We're ready to solve it. Take the square root of both sides. Again, I do it separately. And now I'm going to have that x minus 3 equals, well, let's see, the square root of negative 5. That must be I root 5 over the square root of 4 is 2. Okay, and don't forget the plus and minus. I always do. And then you're going to add 3 to both sides. So x is going to equal 3 plus or minus I root 5 over 2. And that looks like it. That is our answer. All right, do we have another one? No, that's the end of the examples. There's something about the, what is that, the simple interest formula that I'm going to cover with you in class on Monday. So let's see, we'll leave it at that for now, and yeah, that'll be it. All right, thank you, and talk to you later.